Happy morning, students. Welcome to Brewster's High Secondary School online classes. Last class we have discussed about Unit 5 magnetism and electromagnetism. What is mean by magnetic field lines, magnetic flux, and properties of magnetic lines of force we have discussed. So, in this class we will discuss about what is the magnetic effect of current. So, the 21st April 1820, Hans Christian Ørsted. She was a Danish physicist. One day, he was giving a lecture on the students. So, he was demonstrating the electrical circuit. We are already seen at parallel circuit, series circuit. So, the Hans Christian Ørsted demonstrated the electrical circuit in that class. So he switch off the circuit and switch on the circuit. At one point, he noticed that he switched on the circuit, the magnetic compass was deflected on the table. So anyone can't notice that, but the worst was noticed that the magnetic compass is what is this deflected. So she was thinking about here something is happening. He thinking about the magnetic compass deflected. So he finished the class. After the sometimes he to find out a magnetic effect of current. He was experimenting a magnetic effect of current. First, he taken a XY wire pointed the north and south pole. This is the X and Y. X, Y. And he put a compass, magnetic compass. That is A and B. So one compass is fixed about the nearby the X and the another compass is fixed by the near to the compass B. First, the circuit is opened. So the current is passing, but the circuit is open. So the compass, the magnetic compass is not deflected. Already we know that என்னது க்ளோஸ்டு சர்க்கியூட்டா இருந்தா மட்டும்தான் நமக்கு கரண்ட் பாஸ் ஆகும் அப்படின்னு சொல்லிட்டு. ஸோ இதுல என்னது ஓப்பன் சர்க்கியூட்டா இருக்கு, அதனால என்ன ஆகல கரண்ட் பாஸ் ஆகல. அதே மாதிரி காம்பஸ்ல என்ன ஆகல டிஃப்ளெக்ஷன் காட்டல. ஆஃப்டர் ஹி க்ளோஸ் the circuit and current was passing. So the compass is deflected. Compass is deflected because this is the current carrying conductor. கரண்ட் பாஸ் ஆகும் போது இந்த சர்க்கியூட் நீடில் வந்து என்ன கட்டுச்சு, நார்த் சவுத் போல கட்டுச்சு. அதே கரண்ட் பாஸ் ஆனோம் இந்த ஏ காம்பஸ் ஈஸ்ட் சைடு நமக்கு பாயிண்ட் அவுட் பண்ணுது. அதே மாதிரி காம்பஸ் பி வந்து வெஸ்ட் சைடு என்ன பண்ணுது நமக்கு இண்டிகேட் பண்ணுது. ஓகேவா? ஸோ இதுல இருந்து ஒரு ஸ்டெப் என்ன சொல்ல வராருன்னா, இந்த கரண்ட் கேரிங் கண்டக்டர்னால என்ன ஆகுது? மேக்னெட்டிக் ஃபீல்டை ப்ரொடியூஸ் பண்ணுது. ஸோ in this experiment to show that current carrying conductor produces a magnetic field around it. First, the magnetic effect of current is find out the Hans Christian Oerster. She was a Danish physicist. So, the direction of the magnetic lines around a current carrying conductor can be easily understood using the right hand thumb rule. That is Fleming's right hand thumb rule. First, we learn about what is this Fleming's right hand thumb rule and Fleming's left hand thumb rule. First, think you stretch the fingers like this. So, the forefinger indicates the one person, the thumb is upward, and the middle finger is perpendicular to the forefingers. So, if the current carrying conductor indicates that right hand thumb rule. So, the thumb is indicate that the motion of the force, direction of motion of the force. F. The forefinger is indicates that the magnetic field. So, next the middle finger is indicate that the what is this? The direction of the induced current. So, the thumb is indicates that the direction of the motion of the force, and the forefinger is indicates that the magnetic field, and the middle finger is indicates that the induced current, direction of the induced current. So, the magnetic field and induced current is perpendicular, each to perpendicular. So, this is the Fleming's right hand rule. It is also called as generator rule. The next one is Fleming's left hand rule. So, you also stretch the finger like this picture. Same, the thumb is upward and the forefinger is pointed the other person. Next, the middle finger is perpendicular to the forefinger. So, same for the Fleming's left hand rule. The thumb is denoted by the what is this direction of motion of the force, and the forefinger is indicate that the magnetic field, and the middle finger is indicate that the direction of the current. Same for the magnetic field and current is perpendicular each other. Fleming's right hand and left hand rule ரெண்டுமே என்னது fingers வந்து அதே டைரக்ஷன் தான் காட்டுது. பட் ரைட் ஹேண்ட் ரூல் அண்ட் லெஃப்ட் ஹேண்ட் ரூல் ரெண்டுமே என்னது ஆப்போசிட்ல இருக்கும். ஓகேவா? The current carrying conductor at the magnetic field at a point, the wire is depends on the some following characters. That is, the first one is the current in the wire. The second one is distance of the point from the wire. Third one is the orientation of the point from the wire, and the magnetic nature of the medium. So, these following are depends on the current carrying wire. So, this is the magnetic effect of current. First, the magnetic effect of current carrying conductor. Find out the who are Hans Christian Oerster. He was a Danish physicist. How to he found out the magnetic effect of current we learned about. The next one is force on a current carrying conductor in a magnetic field. H.A. Lawrence found that a charge moving in a magnetic field in a direction other than the direction of magnetic field experiences a force. It is called the magnetic Lorentz force. First, the worst step find out what is this. The current carrying conductor contain deflected, but the H.A. Lawrence find out the current carrying conductor experiences a forces. But the worst not to explain the force. But the H.A. Lawrence found that the current carrying conductor, that is the charge moving in a magnetic field, that magnetic field experiences a force, that is called the magnetic Lorentz force. That force is called magnetic Lorentz force. So the current carrying conductor moving the charges, positive negative charges is flowing through a conductors. This current carrying conductor placed in a what is this magnetic field. So that indicates the direction of the magnetic field. The magnetic field also produces a or experiences a what is this force. So it produces a motion in the conductor because he experiences a forces. This force will be produce a what is this motion in the conductor. You will do the small experiment. First you will take in a cardboard and the thread or a wire perpendicular through the cardboard. So this wire connected to the such that the current flow of the wire. So அதில் என்ன ஆகணும் கரண்ட் வந்து பாஸ் ஆகணும் அந்த மாதிரி நம்ம என்ன பண்ணிக்கணும் ஃபர்ஸ்ட் அதை மேக் பண்ணிக்கணும் ஓகேவா ஸோ switch on the current in the circuit so the current flows in the wire after the magnetic compass put on the near to cardboard and mark the positions. So the magnetic compass gives the directions. So this direction is closed circuit. So the magnetic field lines are closed and continuous circles. So the magnetic field lines are perpendicular to the current because these threads are current showing conductor current force. So you draw the positions of the lines, that is direction of the points you draw it, that is the circle. So the circle is perpendicular to the current. So in this experiment, we find out the current carrying conductor exert a force on the compass needle. After that, Michael Faraday discovered that a current carrying conductor also gets deflected when it is placed in a magnetic field. So you can see that the magnetic field or the permanent magnet and the magnetic field produced by the current carrying conductor interact and produce a force on the conductor. So this is the permanent magnet. So the current carrying conductor, the magnetic field is perpendicular. The இதோடைய எப்படி வந்து கரண்ட் ஃப்ளோ ஆகி வருது அப்படின்னு சொல்லிட்டு தான் இந்த பிக்சர் மென்ஷன் பண்ணியிருக்காங்க. அதுல மேக்னெட்டிக் ஃபீல்ட் எப்படி இருக்கு அப்படின்னு சொல்லிட்டு காமிச்சிருக்காங்க. ஓகேவா? ஸோ இதுல வந்து கரண்ட் ப்ரொடியூஸ் ஆகல. இதுல என்ன ஆயிருக்கு? கரண்ட் ஃப்ளோ ஆகுது. ஓகேவா? You will see the magnetic field and current is perpendicular. So this is the magnetic field lines. This is the current flowing. Each two perpendicular. The current is perpendicular to the magnetic field. So same picture. So deeply you see the current and magnetic field lines. So this is the permanent magnet. This is the magnetic field lines. So the current flowing, the conductor. So the Michael Faraday find out the compass also deflected and the magnetic field is what is this? Extractive force and magnetic field perpendicular to the directions. So first the overhead step is what is this? Find out the current carrying conductor is deflected. Something happening. The next H.A. Lawrence, the current carrying conductor experience a force. The Michael Faraday discovered that the current carrying conductor also deflected and perpendicular to magnetic field and force extracted. So if a current that is I flowing through a current length is L, the current is perpendicular to the magnetic field B, then force experienced by it is given by the equations. So F equal to current, length and magnetic field. So this equation indicates that the force is proportional to the current to the conductor, length of the current and the magnetic field in which the current carrying conductor is kept. So this equation indicates that the current is directly proportional to the conductor. So next we will learn about one problem. That problem is based on the what is this formula F equal to ILB. So a conductor of length 50 centimeter carrying a current of 5 ampere is placed perpendicular to a magnetic field of induction 2 into 10 power minus 3 Tesla. Find the force on the conductor. So we have a length and current magnetic field. So apply a formula. Force on the conductor, what is this formula? ILB. We have a I current, L length and magnetic field. I equal to what is this? 5 and L equal to 50 centimeter. Next B equal to 2 into 10 power minus 3. So 5 into 50 into 10 power minus 2 into B magnetic field 2 into 10 power minus 3. So 5 into 10 power minus 3 Newton. This is the force on the conductor 5 Newton. 5 into 10 power minus 3 Newton. The next problem is the current carrying conductor of a certain length kept perpendicular to the magnetic field experiences of force F. So what will the force if the current is increased 4 times, length is halved and magnetic field is tripled? So in this problem we can't given a what is this numbers. So what is this? 4 times increased length. So I equal to 4 into I, and the length is halved, that is L divided by 2, and the magnetic field is tripled, so 3 into B, so 6 force. So the force is increases the 6 times. So next one is for some parallel current carrying conductors. So already we know that the current carrying conductor have a magnetic field. First we put a two current carrying conductor, each two parallel. For example, you see the picture. Okay, the second current carrying conductor will experience a force because the first conductor in a magnetic field, due to the second conductor will experience a force. The first conductor will experience a force due to the second conductor magnetic field. So the two forces will be equal in magnitude, but the opposite directions. The magnitude is same, but the direction is opposite. So using Fleming's left hand rule, we can find the direction of the force on each wire. So both the conductors carrying current. The first picture, we will see in the first picture. So the current is flowing the same directions. So the wires are attractive because the current is flowing the same direction. You will see the current, that is I1 and I2. So each the wire is attractive. So the next one is the same parallel conductor. To pick a parallel conductor, the direction of the current is opposite. So each of the wire is repulsive. You will see the current is flowing through this side, and the current is flowing the opposite directions. So each of the wire is what is this? Repulsive. இது எப்படின்னா கரண்ட் வந்து சேம் டைரக்ஷன்ல இருக்கும்போது ஃபோர்ஸ் வந்து என்ன ஆகுது, அட்ராக்ட் ஆகுது. ஓகேவா? ஸோ அட்ராக்ட் ஆகுதுன்னா ஃபோர்ஸ் வந்து அட்ராக்ட் ஆகுதுனால இந்த ரெண்டு ஒயருமே என்ன ஆகுது, அட்ராக்ட் ஆகுது, ஒன்று ஈர்த்து கொள்ளுது. ஓகேவா? நெக்ஸ்ட் இந்த கரண்ட் வந்து ஆப்போசிட் டைரக்ஷன்ல போகும்போது என்ன ஆகுதுன்னா ஒவ்வொரு கண்டக்டர்லயும் ஆப்போசிட் டைரக்ஷன்ல போகும்போது என்னன்னா ஃபோர்ஸ் வந்து ரிப்பல் ஆகுது. ஓகேவா? Already we know that like charges repel and unlike charges attract. Same form of use this. So எப்பவுமே என்னது, லைக் சார்ஜஸ் வந்து ரிப்பல் பண்ணும், அன்லைக் சார்ஜஸ் வந்து அட்ராக்ட் பண்ணும். அதே மாதிரி தான் இங்கே என்னது, கரண்ட் வந்து சேம் டைரக்ஷன்ல போகும்போது அட்ராக்ட் ஆகுது, அதாவது வேற டிஃப்ரெண்ட் டைரக்ஷன்ல போகும்போது என்ன ஆகுது, ரிப்பல் ஆகுது. ஓகேவா? இதுக்கு முன்னாடி நம்ம பிக்சர் பார்த்தோம்ல, அதே தான் நமக்கு இங்க மேக்னெட்டிக் ஃபீல்ட் லைன்ஸ் கொடுத்துருக்காங்க. ஓகேவா? ஸோ கரண்ட் வந்து எப்படி ஆகுது, இன்வர்ட்ல வருது. ஓகேவா? இது கரண்ட் என்ன ஆகுது, இன்வர்ட்ல வருது. ஸோ ரெண்டுமே ஒரே டைரக்ஷன்ல இருக்கும்போது நமக்கு ஃபோர்ஸ் வந்து எப்படி இருக்கும், அட்ராக்டிவா இருக்கும். ஸோ நெக்ஸ்ட் என்னது, இதுல வந்து கரண்ட் வந்து அவுட்வர்ட் டைரக்ஷன்ல இருக்கு, இதுல இன்வர்ட் டைரக்ஷன்ல இருக்கு. ஸோ ஃபோர்ஸ் வந்து எப்படி இருக்கு, நமக்கு ஆப்போசிட்டா இருக்கு. இதுல ஏரோ மார்க்ஸ் பாருங்க, எல்லா ஃபோர்ஸுமே ஒரே டைரக்ஷன்லயே இருக்கு. ஓகேவா, சாரி, எல்லா கரண்ட்டுமே ஒரே டைரக்ஷன்லயே இருக்கு. நீங்க ஏரோ மார்க்க பார்த்தாலே தெரியும், எல்லாமே என்ன ஆகுது, ரைட் டு லெஃப்ட்ல போகுது. அதனாலதான் என்ன ஆகுது, ஃபோர்ஸ் வந்து அட்ராக்ட் ஆகுது. இங்க பாருங்க, கரண்ட் வந்து ஒன்னு வந்து அவுட்வர்ட் டைரக்ஷன்ல, இன்னொன்று வந்து இன்வர்ட் டைரக்ஷன்ல இருக்கு. ஸோ தி ஃபோர்ஸ் இஸ் ரிப்பல்சிவ் ஃபோர்ஸ். பாத்தீங்கன்னா தெரியும், இது வந்து என்ன ஆகுது, லெஃப்ட் டு ரைட், இது ரைட் டு லெஃப்ட் டைரக்ஷன்ல இருக்கு. ஸோ தி ஃபோர்ஸ் இஸ் ரிப்பல்சிவ். So in this class we have learned about magnetic effect of current. First find out the who are find out Hans Christian Orestel. So current carrying conductor have a deflections. The next one is H.A. Lawrence. So H.A. Lawrence found that the current carrying conductor also experiences a force. The last one is Michael Faraday discovered that the current carrying conductor also gets deflected when it is placed in a magnetic field. Next we have here 1 or 2 problems, and next one is force on parallel current carrying conductors. So same direction of the current, the force is attracted. The opposite direction of the current, the force is repulsive. I believe that all of you do a homework and observation note. Any doubt, ask me and clarify that the doubt. Thank you, students.